Greetings of the day. Welcome to the course on Operations Research Technique. In earlier lectures, we have seen in unit number 1 the very first model, that is linear programming problem, where the objective function was either maximize or minimize, and any industrial problem, real life industrial problem, can be solved with the concept of linear programming problem. We called it as LPP or LPP problems or LPP model. Now today we will start with unit number 2, in which we will come across assignment models and transportation model. It is application of the concept of linear programming problem. So in case of linear programming problem, we have seen that we can convert the given problem into equivalent linear program. The same thing is also done in case of assignment and transportation problem, but here it is specified to that particular domain of assignment or transportation. So it is advanced application of the concept of LPP, wherein we are using that concept for the domain of assigning some facility to related facility or transporting commodities from origin to the destinations. So we will go into details of transportation after finishing assignment models, and now let us see what we are supposed to learn in assignment model. So here I have given you the complete definition, and I will explain each and every point mentioned in the slide so that you are comfortable with what are the contents, what we are aiming at in assignment models. So as the name indicates, assignments means to fix some facility to some other related facilities from the point of view of optimizing the objective function. Now again the same aspect, your optimization can be either maximization type or minimization type, depending on the situation. If it is profit oriented, it will be maximization. If it is cost oriented, it will be minimization. So we will see that an assignment problem is a particular case of transportation problem, which is taken from linear programming problem, and as said, the resources which are referred as facilities are assigned or to the destinations are activities. Means what we are doing, we are assigning some facilities to the destinations. In transportation we are using the word origin and destination. Here we will be using the term from facility to facility in assignment models. Now the objective function, which is referred as effectiveness of the problem, is maybe in the terms of cost, profit or time. So domain may be given any, you can give any name to the objective function, but depending on the category, which term, if it is cost, objective function will be assign the facilities to related facilities in such a way that cost of performing those tasks is minimum. If I am looking from the profit point of view, I will assign the facilities to related facilities such that my profit will be maximized. Same time will be minimized, like that. And here what is important, the problem of assignment arises because the resources that are available, such as these are the resources we have seen in very first lecture, 5 M's: man, machine, method, money, material. 5 M's are available in varying degree of efficiency for performance of different activities. This term, varying degrees of efficiency, is important. Facilities are available, but their effectiveness of use is different. So we have to plan in such a way that we have to assign facilities such that overall effectiveness of the problem under consideration is optimized. Again, optimize, maybe maximize or maybe minimize. So after looking this particular definition, let's move to further part. Now this is very important. What are the various areas where we can use the problem of assignment. Some of the problems where assignment technique, the techniques which we are studying in this lecture will be assigning workers to the machines. This is very important, assignment of workers to the machine, because in factories workers or operators will be operating on different machines. So depending on the skills of the operator on those particular machine, as a decision maker, as supervisor, you have to plan, you have to assign the task to the operators considering their effectiveness of performance of different operations with different machines. So as to optimize the objective function, you are supposed to assign workers to various machines. Salesmen to different sales areas. We know the example of medical representatives in which they are moving from different cities to various different cities, and they are resident of one particular city. So here the purpose objective will be to minimize the total time cover during their movement from cities to cities, at the same time to minimize the cost of moving from different cities to different cities starting from the main city. Or in most of the industries we find that for selling the items, salesmen are deputed and salesmen are paid different allowances. So intention of any organization will be to minimize the expenses, and from the point of minimizing expenses, again it is the decision makers who has to, with proper care, assign different salesmen to different sales areas or different cities. Clerks to various checkout counter. Whenever we talk of service industry, many people are deputed to provide services, and whenever we are talking of services, while taking service from the system, we many a times find there are formation of long queues, waiting line. Our intention should be such that the waiting line should be minimum. Customer is not required to wait for longer duration. At the same time, again looking to the effectiveness of these clerks, various counters are allocated to these clerks so as to optimize the process. Classes to the rooms. This is related to educational institute, where we are having different students in different semesters, different sections, and the institution is having as an infrastructure facility different classrooms and laboratories. So effective utilization of these classrooms by assigning different sections to the students is done with the help of assignment problem. Vehicles to routes. This is a very important application again of assignment problem. We know that school bus, what school bus does? It picks students from different corners of the city and take all the students on the route to the school, and when the school is over, again the same bus follows the same route and return the students to their residences. So here, if we are not optimizing the route through which the bus should move, it will cost more to the management. So assignment problem concept is used while assigning different vehicles to different routes. For maybe industry persons working in different industries, we know that most of the industries, they are having their bus facilities, transport facilities. They pick their employees from some destinations and take to the company and return to the same spot where from they have picked the students or employees. So in such cases, we can take the example of assignment problem. And here the last quoted is, there are different government or private contracts where contractors are doing the job, and for that the tenders are opened, and depending on the cost parameter and the conditions which the bidders have fulfilled. So it is the task of the decision maker to assign different contractors to different bidders, different tenders, so as to get the work done with effectiveness within stipulated time, within minimum cost involved in the projects. So these are various possible areas where we can use the concept of assignment problem. Now we have seen that assignment problem and transportation problem, they go hand in hand. So let's see in brief what is the major difference between these assignment and transportation problem point wise. So I have written here some point. I will explain those points and will be in a position to understand the precise difference between two aspects of decision making, which are nothing but one is transportation and other is assignment. So we will be here left hand side, you can see transportation problem, and right side is assignment problem, and here the parameter through which we are differentiating between these two aspects. Got it? So now size of matrix, this is very first, size of matrix. In transportation it is written square and non-square, it is only square. I will explain it through this simple matrix. Now what I did is I have drawn here 3 by 3 matrix, and here I am drawing some other size of matrix. You can identify the size, it is 4 by 3 matrix. This matrix is 4 by 3 matrix and this matrix is 3 by 3 matrix. So remember students, the very important condition when you are attempting problem with the help of assignment model is you must satisfy this condition only square. Means number of rows and number of columns of the given matrix before we proceed has to be square one. If it is not square, we have to make it square. Ensure that before you proceed for finding answer, finding solution to the problem, you are attempting it as a square matrix. Whereas in case of transportation, the condition may be either you can attempt transportation problem by this 3 by 3 matrix or a non-square matrix where number of rows and columns are not same. That is the meaning of first point. I think it is very clear. Is it? Now second point, allocation. Allocation is nothing but assignment. First we will see this, only one allocation in each row, only one allocation in each row and each column. See here, suppose I am talking of man, different man, man 1, man 2, man 3, and here I am writing machine, machine A, machine B, machine C. Now here in this problem of assignment, we are having 3 workers in the form of man 1, man 2, man 3, and 3 machines, machine A, machine B, machine C. So here one worker will be assigned only one machine. So each row and each column will have only one assignment. That is very important because there is squareness in the behavior of matrix. So you cannot assign man 1 to 2 machine, or vice versa, 2 machines cannot be assigned to single operator, one operator. So it is 1 to 1. So either ABC will be assigned to 1 or ABC will be assigned, any one of ABC will assign to 2 or 3, like that. So 1 to 1 assignment in case of assignment problem. But here suppose I am saying for this it is from city and to city, from city, suppose I am writing 1, 2, 3 as the name of the city, again A, B, C, D as the cities. Now here you can see, we will see this detail in transportation problem, here suppose I am having some supply quantity, here I am having some demand quantity, and suppose here the supply from city 1 is 50 units, or from city I can write also from factory. So this 50 I may divide like 1040, or one may divide it like not exactly 1040, one may write as say 3020. Second option, depending on the problem, or one may write only 50 as a supply from this 1 to C. So here, as we have seen, the condition is only one in each row and column. You will be having only one allocation. Here, as written, each row and column may have more than one allocation. So this is one allocation. In earlier two examples, I have shown more than one allocation. So that is possible only in transportation problem. Got it? Third, main requirement. This is very important. Supply must be equal to demand. Whenever you are attempting for any solution to given problem, transportation problem, the first very essential condition, which is also called by many authors as RIM condition, R-I-M. RIM condition is that total supply must be equal to total demand. If not, we have to make it by adding dummy supply or dummy demand, and then we have to balance it. That is total, including if it is not dummy supply or dummy demand. But before you start with first step, you have to be very sure that supply is equal to demand. That you have to check. Then only you can proceed. Here, no such condition. No such condition. There is no question of supply and demand. But only square matrix. Assignment problem, you cannot proceed for finding solution to a assignment problem unless and until you make the matrix square one. If it is non-square matrix and if you are attempting assignment problem, it will not work. For assignment problem, the very first condition may be maximization type, may be minimization type. The very first condition will be it has to be a square matrix. Got it? Students, it has to be a square matrix. Whereas in case of transportation problem, total supply has to be equal to total demand. If it is not given in original problem, then you have to add dummy supply or dummy demand, make supply equal to demand, and then proceed for solving. Mind well, when you proceed for solving transportation problem, it may be a square or non-square. But again I am repeating, it may be a square or non-square, but total supply has to be equal to total demand. If you attempt this step of total supply equal to total demand, your matrix may be square, may be non-square. In case of transportation problem, hardly matters, but for this assignment it has to be a square matrix. Third point. And fourth, objective function, for which we are attempting to solve the problem. See, in both cases the both method is applicable for both, that is minimization type of objective function, maximization type of objective function. Similarly, assignment model is applicable for minimization and maximization type of objective function. So I think the difference between these two aspects is very clear. Now again, whenever I will be switching over to transportation problem, I will remind you that we have seen this particular slide. I will just narrate what is the difference point wise at that point of time, but right now I think you got what is the condition required and what is the precise technical difference between transportation problem and assignment problem. Let's move further. So now we have seen in earlier linear programming problem that we are formulating mathematical equations and we are writing objective function from given wording problem. In the similar linear equivalent linear program format, we can also write assignment problem. So here I have shown you, if you can see here, in a correct manner I have shown assignment problem mathematical model. Assignment problem mathematical model. Now what is giving? See here, I have shown you in earlier case a matrix. Here you can see this, I am drawing now a square matrix 4 by 4. Again let us label man. I will label say man as A, B, C, D, and machine E, F, G, H. See here nothing is written, means only one person belonging name A is available. 1 here, only one person, 1 since it is 1 we are actually it is 1 it is 1 means one man B category, one man of C name, one man of D name, one machine naming E, one machine naming F, one machine H, one machine G, like that. And suppose I assign like this, the meaning of this is, this problem indicates that man A is assigned machine F. Let us, for understanding, I write like this. Suppose this is the solution to the problem. Here the assignment is read as man A is assigned a machine F, man B is assigned machine E, man C is assigned machine G, and man D is assigned machine H. Hypothetical way we are saying to understand the meaning of this model. Now here, since you are having only one man A, so this is being assigned to machine F, which is only one. So when there is assignment Xij is equal to 1, Xij is equal to 1 if ith facility is assigned to related jth facility. See here, I have assigned ith facility, I go row wise, ith facility means man A, I have assigned man A to jth facility, J goes by column, machine F. One machine, one man, so it is 1. Xij is equal to 0 if ith facility is not assigned to related jth facility. Here you can see blank, means 0. Clear? So it is never written like this, so I will rub it. I will rub this. Since it is 1, it is not written. Now objective function may be basically originally the problem, originally we will solve all assignment problem with objective function minimize. So what we will do, if objective function is profit which is in term maximize, we will convert that into equivalent minimize form, as we did in transposition from minimization to maximization. If you remember, in the last lecture I have given you how to convert equivalent linear program of minimization to maximization. In the similar fashion, with some different steps, we can convert profit assignment problem pertaining to maximization type of objective function to corresponding minimization type of problem, and we will attempt the solution of that problem with the help of minimization method. So when it is assigned, so minimum total cost will be, it is given as double summation, I ranging from 1 to n, j ranging from 1 to n. Here you can find n because of the main condition, that is it has to be a square matrix. Since the condition is square matrix, I number of rows are ranging from 1 to n and number of columns are also ranging from 1 to n. Cij and Xij. Cij is this particular, see now, this is 4 by 4 matrix. This is 4 by 4 matrix, and in this matrix, this particular which I am drawing by green color, suppose I am indicating, this portion is called as cell, CELL, cell of the matrix. This is called as cell of the matrix. Now, again importantly, suppose we are having values to, I am writing arbitrarily 5, 4, 7, 8, 1, 3, 10, 2, 4, 11, 17, 18, 8, 9, 10. I have written the values arbitrarily. The meaning is this 1, this 2 is nothing but this is Cij. I row, j column. I row, j column. So all these values which I have written with the blue color pen are Cij's values for this 4 by 4 matrix. All these are Cij's values. Now, suppose I want to find the objective function, what I will be doing? I will be multiplying the allocated quantity which is either 1 or 0. Xij is either 1 or 0. 0 means when there is no allocation, 1 when there is allocation. So you will be multiplying these values either with 1 or 0. And what we are doing? We are adding summation of rows and columns. So therefore the sign is double summation. Suppose I get this assignment as like this, mark assignment. So here the cost will be 5 plus, this is 8, 5 plus 8 plus 13, 13 plus 11, 13, 14, 24, 34. So for this cost parameter, I will see the problem in detail, will be 34. And these are the equations for rows I ranging from, whenever you are, now here for this matrix which I have shown, we will be getting 4 equations for rows, you will be getting 4 equations for columns, since it is 4 by 4 matrix. So this is in general linear programming problem for equivalent linear program for assignment problem. Now the scientist Hungarian has given special method, has developed special method to solve assignment problem. He has developed special method to solve assignment problem. So here the Hungarian method developed by Hungarian mathematician D. Koenig is an efficient method. It is a very special design method for finding optimal solution of an assignment problem without making direct comparison of every solution. We will be starting from very initial position and will terminate our algorithm when we reach to final solution. The Koenig, scientist Koenig from Hungarian developed this method, and therefore in his respect it is referred as Hungarian method. Now this can be used for both objective function which may be maximize or minimize. For both objective function this Hungarian method is suitable. So let's have a look. I will explain the steps and then we'll solve one problem by this particular Hungarian method. Now again I will remind you, to avoid confusion, what we'll do? We'll be understanding the concept, all important aspects related to maximization type of assignment problem, minimization type of assignment problem. And what we'll do? If the problem demands maximization type of objective function, in the very first step we will convert that problem into minimization objective function, and we will follow the same steps which are written here for maximization. So again, to thrust, our steps are for which one? Minimization type. It doesn't mean, remember, it doesn't mean we cannot solve maximization problem. Yes, we can solve maximization problem, assignment problem by the same method, but what we'll do, very first step, we'll convert given maximization type problem into first minimization category, and then we'll attempt all these steps. We'll do that whenever we'll come to problem pertaining to maximization type. Now let us look the various steps of Hungarian method of finding solution to assignment problem. So I will explain the steps in detail, and based on these steps what we'll do, we'll solve one problem. Now first step, develop cost matrix from the given problem. Yes, you have to develop from the given data a square cost matrix. Square, what is the important condition? Square matrix. You have to develop square cost matrix from the given data. Second, perform, these are the steps we will see. Perform row reduction, if required perform column reduction. You just write all these steps in your notebook. While solving problem, I will explain the details of each step. Right now what you can do is, you can write these steps in your copy. First is, you have to develop square matrix, perform row reduction, if required, this is very important, if required, very important, perform column reduction. Make assignments in opportunity cost matrix. The reduce matrix after doing this row reduction and column reduction which we are getting is referred as opportunity cost matrix. In that we have to make assignment. We will see how to make assignment. Then see the optimality criteria, whether the assignments which you got in step 3 are optimal. For that you have to move to this step 5, that is revise the opportunity cost matrix. If your solution is not optimal, if your this fourth step is not optimal, you have to follow step 5. Develop new revised opportunity cost matrix. So here again this is important. If you are not satisfied with solution, or if the meaning of not satisfied means if your solution is not satisfying optimality condition, then you have to develop the new revised opportunity cost matrix. And 7, repeat the steps from 3 to 4. So this is looping. This is looping from step number 3 to step number 6 till optimality criteria is satisfied. Till, this is repetition from 3 to 6 till your optimality criteria is satisfied. These are the steps. Now we will see details of this step number 5. See, this is step number 5 with details. These are the details. Now you just only note these steps. I will be explaining each and every step mentioned over here while solving problem, but you can read in bold blue ink, if number of lines drawn or total assignments is equal to the number of rows or columns, current solution is optimal solution. This sentence you remember. When current solution is optimal, condition is given in the beginning, if number of lines drawn is equal to the size of matrix, that is number of rows or number of columns, and if the number of lines drawn means covering all assignments, all zeros. Again, this point will be made clear when we will solve problem. And this problem, this particular slide I will be explaining when we will be solving the problem and we reach to step number 5. What I will do, I will first remind this particular slide and then I will apply all these A, B, C, D, E criteria for that problem, so that you can have connect direct link between the steps mentioned and steps executed while solving the problem. Now let's move with very basic problem. See here. Now we'll start with problem. A machine tool company, this is problem. A machine tool company decides to make four sub-assemblies, I am putting that in bracket, through 4 contractors, means pair of sub-assemblies and contractor. How many sub-assemblies? 4 sub-assemblies. And how many contractors? 4 contractors. Each contractor is to receive only 1 sub-assembly. So that is the basic in linear assignment, that in each row and each column you will be having only 1-to-1 assignment, that we have seen in the beginning. So this sub-assembly 1 will go to any one of this 1, 2, 3, 4 contractor, or vice versa. I can say 1, 2, 3, 4 out of these 4 contractor, only one will receive any one sub-assembly of the category 1, 2, 3, 4. So here contractors are 4, sub-assemblies are 4. Here we can rename if we wish, that contractors, suppose I give here, instead of 1, 2, 4, I can write A, B, C, D as a, if 1, 2, 3, 4 is confusing to you, you can write contractor name A, contractor name B, contractor name C, contractor name D. Names of the contractor, names, this is the code of sub-assembly. subassembly, 4 total subassembly, first subassembly, second subassembly, third subassembly, fourth subassembly. It will go to, now the problem will decide to whom to allocate these subassemblies by 1-to-1 combination. The cost of each subassembly is determined by bids submitted. Bids means the tenders is float and these contractors have submitted their, responded to the quotations and they have submitted what will be their cost of performing these duties. And it is given in hundreds of rupees. See how to read it. Now for subassembly 1, the contractor A has given his quotation as 1500. It is not 15 rupees, it is 1500 because it is given in hundreds of rupees. So likewise this is 1300, this is 1400, this is 1700, means all these values of the matrix are multiple of 100, got it? All these values are multiple of 100. So 1700, 1400, 1200, like that. Assign the different subassemblies. What is the ask? Assign different subassemblies to contractors so as to minimize the total cost. So objective function is very clear now. What is the objective function? You have to solve this problem for minimization of cost. Means assign these 4 subassemblies to 4 contractors 1-to-1. Each contractor will receive only 1 subassembly out of these 4, or vice versa. Again I will say any one subassembly will go to any one contractor, but your task as an engineer, as a decision maker, is such that do not assign arbitrarily to any contractor. Follow the Hungarian method, follow the standard technical method and find which is the correct assignment that will result in minimizing cost of these subassemblies being done through these contractors. So if you recall, these all are Cij values. Means this is first is Cij, I first, J first, 1 1, C12 first row second column, C13, C14, C21, C22, C23, C24, likewise C42, C43, C44. So these are the cost values. What we have to do? We have to assign these values to different contractors in such a way that we are getting the effective utilization of these contractors with the subassemblies and resulting in minimization of cost. So we have seen today the basic requirement of assignment problem. We have seen what is assignment problem. We have seen the conditions required for assignment problem. We have seen the structure of assignment problem as you can see on this slide. I have explained all details of assignment problem, and now from next lecture what we will do? We will go for finding solution of this particular problem from assignment point of view. So till now, today we will be stopping at this particular point, and in next lecture, in coming lecture, we will see how to solve this particular problem. Till then, you can practice this particular given problem as a various to note various contents given in the problem. So we will see its solution in coming next lecture.